Hello, hello,
Hello, ma'am.
hello.
Yes, ma'am, we can hear you.
Hello,
Yes, madam.
can you hear me? Hello.
Yes,
Yes,
Yeah,
ma'am.
I'm good. Yeah,
Yes,
how
ma'am.
are you?
I'm fine.
Yes, ma'am.
We're fine, madam. What about you?
Yeah, I'm fine. Thank you. Okay, so we were supposed to start Q today, but please let me know whether you have any problem in the previous topics, the previous data structures that is in array, linked list, and stack. Is there anyone who have still confusion in array, linked list, or stack? We already discussed three types of linear data structure, right? One
Yes, ma'am.
was array, and number two, linked list, and the third linear data structure was stack. So before starting another one, I need to know whether you have any problem in this three data structure. What about stack? Do you have any problem in stack in postfix to infix conversion or from postfix to infix?
No, ma'am.
No, that's great. Okay, so today we'll start Q. So what is Q? Linear data structure, right? That means we can store the data in some consecutive memory locations, isn't it? And just
Yes, ma'am.
like the stack, obviously Q can be represented in array as well as in linked list. Okay, so Q is linear data structure, and if we now consider this structure as Q, and suppose we have some data elements such as 10, 20, 30. Okay? Just think about the previous data structure that we discussed, stack. If the same data we want to store in stack, how we can do it? In stack, one end is open and one end is closed. So in this open end, we can insert any data element, and from the top of the stack, we can delete any data element. Isn't it? So what about
Yes,
queue?
ma'am.
In this queue, both these ends are actually open end. This is the front side of the queue, and this is the rear side of the queue. Okay, and now in queue, insertion and deletion should be performed on different sides. Queue is a linear data structure where we can insert some data elements. So initially the queue is empty. Okay, and suppose we don't know what is the size of this queue. So if we want to insert 10, we can place it in the first memory location. So why we are actually inserting the new element in the beginning of the queue, right? And for denoting the position of the first data element, or for denoting the position of the front side of the element, we need a pointer. So this front pointer will be used for representing the value of the first data element. So when we inserted 10 in this empty queue, now the queue has one element and its position is 1, so we can assign the value 1 to this pointer front. So what about rear? Unlike stack, we have to use two variables for queue. Sorry, it's rear. When we inserted a data element at that time, the front value was 1. What about the rear value? 10 is the only element of the queue, that's why both pointer front and rear will have the same value 1. Now if we want to insert another item that is 20, where we will insert it? In data structure stack, both the insertion and deletion performed on one end, that is the top of the stack. Suppose 10 is the first data element, so we can insert it, and after that we can use the same end, that is the rear end, for inserting the data element. But in queue, suppose this portion, this is the beginning of the structure, right? And after inserting 10, now if we want to insert another item, we'll do it. Yes?
Sorry, ma'am, I was late. I had no electricity, ma'am. Can you
Okay,
just
no
repeat?
problem. Just it's queue. Okay. So just like array, linked list, stack, queue is another linear data structure. So we can store some data elements here. But queue has some special features that it can't find in the other data structures. And one important feature is in queue we have to use two pointer variable. One is front and another is rear. And in stack data structure, we only used one end of the structure, that is the rear end for insertion and deletion, and that's why this data structure is called LIFO, last in first out data structure. But now in this data structure queue, we are going to use both side of the data structure. This is the front side of the queue and this is the rear side of the queue. Okay, so if we have three data elements, 10, 20, 30, how we can store them in this queue? This is the front side of the queue and this is the rear side. So where you should insert the next data element?
Beside 10.
After
Before 10.
Okay.
Ma'am, after 10.
Draw the queue in
From
several
rear.
want, we can represent it horizontally or vertically. Suppose if we represent it vertically, okay, and if it is the front end of the, which one is actually front end?
Upper part.
Okay, so if we consider this as the front end, so 10 will be stored first. After that we can store 20 and then 30, isn't it? Or we just use a wrong method? Don't get confused. This is queue. One end should be taken as the front end and another end should be taken as the rear end. So is this the correct representation? What do you think?
Oh, I think.
No,
I mean, it's look like stack.
it's
30
like stack.
should be
Okay.
before.
So now suppose this is the queue. Initially the queue is empty or we have only one element 10. Now we can store 10 here. So now can we consider this side as the front side of the queue?
Yes. Yes,
Yes,
ma'am.
ma'am.
Okay. So now after that, which end should be considered as the rear end? Where we can insert 20.
Left
Almost
side.
10.
Before 10, ma'am.
Yeah, we know that before 10, but how can we use this representation? Look at this. Suppose this is our queue with one element 10, and after that can we insert another data element that is 20, and after that can we insert another data element that is 30. So at that time we have to consider this end as the front end and this end as the rear end.
Yeah.
Do you get my point? If we consider, suppose I'm just redrawing this figure, this is our queue, and we have three data elements 10, 20, 30. One end should be used as front end, and another end should be considered as rear end. So when the queue is empty, we are inserting the first data element, that is 10. After that, if we add 20, then 30, that means this is our front end of the queue and this is the rear end of the queue, isn't it?
Yes,
And
ma'am.
the position should be written like this: 1, 2, 3. 1, 2, 3. So what will be the value of this front pointer? The value of front pointer will be 1 and the value of rear pointer will be 3. So how we are inserting the new data element in the rear end? So here 10 is the first element that we inserted in this queue, 20 is the second element, and 30 is the third element. So after inserting these three elements, now how we can remove them? Just
By
think
removing the
about
first
a
one.
example of
Ma'am,
queue. So two
first,
people are standing in a line. This is the first person, this is the second person, this is the third person. So the person that came first will be served first, right? This person will get the service first. After that, he can leave the queue. After that, the second person will take the position now. Now it will be the front end element, isn't it? After that, the second person will get the service, then the third one. So here 10 was the first element in this queue, so at first it should be accessed and after that you can remove it. 10 was the first element that we inserted in the
And
queue,
first
that's
up.
why 10 first, and after that we can remove that element. That means here the deletion should be performed on which end? On the front end, and that's why queue is called first in first out data structure. The data element that came first will be served first. So here 10 was inserted first, that's why it will be removed first. Is that clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So this is the data structure queue where we have to use two pointer, one is front and another is rear. And insertion should be done on rear end and deletion should be done on front end. Okay, so now tell me how many types of operations we can perform on this queue. Suppose we have a queue, now we want to insert some data element, and in stack we use some separate terms for denoting insertion and deletion operation. Remember, we use push for insertion operation and pop for deletion operation. In the same way, in this data structure, inserted will be denoted by NQ. Here NQ means insertion and DQ means deletion. Okay. So now if we want to insert a new data element, that operation should be called NQ operation, and deletion operation, that means DQ operation. So in this queue now, if we want to insert another data 40, how we can do it? These are
Adding
the
to
two
rear end.
basic operations that we can perform on queue. Right? One is in queue, another is DQ. But there are some other important features of queue that actually we have to perform before inserting or deleting any data element. Okay, suppose before inserting 40, we need to know whether the queue has the capacity to hold another data item, right? We need to know whether the queue is full or not. So at that time, we can perform another operation which is called is full. And when this operation will be used? Before in queue operation. So we need to check whether the queue is full or not by using is full operation. So is the result of is full is true. That means the queue is full, and at that time it will print a message overflow. When the queue is full, that means we can't insert any data element. That's why the message will be shown, that is overflow. Okay, and suppose the queue is not full, the size of the queue is 5, so it can take more than 2 more items. That means we can add, how we can add the data element 40? If this operation is not true, At that time, we can insert another data item, but before inserting the data item in the queue, we have to increase the rear value by 1. So here, the new value of rear pointer will be 4, where the data can be stored. Is that clear how we are inserting the new data item? At first, check whether the queue is full or not. If it's full, that means we cannot insert any new data item. Otherwise, we have to increase the rear pointer value by 1. Then we can place a new data item in that location. Clear?
Yes.
Another operation can be performed on queue, and that is called isEmpty, and where we actually use it before a deletion operation. So suppose the queue is empty. That means we cannot delete any data item from the queue. So before deleting any element, at first check whether the queue is empty or not. If isEmpty equals to true, that means if the queue is empty, it will print the message under flow. So at that time we can't remove any element. Otherwise, if isEmpty operation is false, that means the queue has some elements. So which one will be deleted first? It depends on the value of front. So here, the value of front pointer is 1. That means this data item will be processed first, and after that you can remove it. After removing these data elements, now the front value will be increased by 1. So this 20 will be the first element of the queue. When we deleted 10, that means now the first element is 20 and its position is 2. That's why front equals to 2, which means we'll get the first data element in which position? In memory location 2. So after that, if we want to delete another data item, that is 20, so after deleting it again, we have to increase the front pointer value. So the new value of front will be 2 plus 1, that is 3. Isn't it? So after deleting this element, now the queue has only one element, and at that time the front value and the rear value will be same. Suppose some values are given, some numbered data elements and some pointer, the pointer value is given, that is rear equals to 1 and front equals to 1. What does that mean? That means the queue has only one data element. Clear? Hello, is that clear?
Yes, ma'am.
Yes, ma'am.
Yes, sir.
And we can add another operation name here, that is peak operation. So what is peak operation? We discussed this thing in stack data structure. Suppose this is the stack with 2 elements, 10 and 20. So what is the topmost element here? Which one? Obviously 20. So here top equals to 2, right? And if we want to insert a new item, at first we'll increase the top value by 1, then we can add the data item in the stack. And for deletion operation, at first this 20 will be deleted, then we can decrease the top value by 1. So in insertion and deletion operation, we are adding some data item or we are removing some data item. But what about this peak operation or top operation? We can call it top operation in stack. So in this operation, we are not actually removing or adding any new data item. We are just accessing the topmost data element, and after that it will return the value of the top. If we perform a pick operation, it will just return the value of the position of the topmost data element. So for this stack, top equals to 2. So after this pick operation, it will provide us the position of topmost data element, that is 2. So what about this queue? In queue there are 2 pointers, one is rear and another is front. Suppose we didn't delete any data elements, so there are total 4 data elements, 10, 20, 30, 40. So the rear value is 4 and front equals to 1. So after this peak operation, it will always provide us the position of the first data element. This peak operation will provide us the position of the first element. So here, after executing this operation, it will provide the result 1. So here 10 is the first data element and its position is 1. Clear?
Yes, ma'am.
Okay. So now we know how to insert or delete the data element from queue. So can you just prepare the algorithm? Can you write the algorithm for in queue and dequeue operation? Or suppose some conditions are given. Suppose these are some data elements 12, 25, 37, 42, 55, and these are the operation. Initially the front value is front equals to 0 and rear equals to 0. What does that mean? That is the stack queue is empty. Okay, so we are inserting some data elements in an empty queue, so we don't need to know the value of front and rear. So can you just at first add three data elements, after that remove a data element, then again insert the data element? Can you do it? The operation is at first add three operand, add three numbers, then delete one, then again add another number, then again delete one number, then again add the last number. Can you do it? Hello? Hello?
Hello, ma'am.
Can you hear me?
Yes.
Yes,
Yeah,
ma'am.
I'm repeating. I'm just asking, look at this. Here, some data element is given, and the queue is an empty queue. So at first, you have to insert three data elements 12, 25, 37, then delete one element. After that, you will get different value of front and rear. Then again, insert another data element. After that, delete one more element. Then insert the last element. Can you do it?
Yes, ma'am.
And another thing, after executing each of these operation, the value of front and rear will be changed, and you have to store the value. Okay. So we just have 5 minutes, so just complete. Hello? Hello?
Yes,
Hello?
yes, ma'am.
Yeah.
Hello,
So
ma'am.
yeah, so there are total 5 elements, right? So at first we'll insert 12. Initially front equals to 0 and rear equals to 0. So after inserting the element 12 and its position is 1, so after inserting it, the value of rear will be 1 and front equals to 1. Okay.
Right.
Now the next operation is another NQ25. So where we can insert that new data element?
In the
Before
rear side.
inserting the data element, we have to create a space for that element, right? So after increasing the value of r by 1, now r equals to 2, and here in this position we can insert another data item. So the queue already has the previous data element, that is 12, and now the new data item 25 will be added. And here we got front equals to 1 and rear equals to 1. Now again we'll insert another data, that is 37. The queue already has 2 elements, and now we'll insert another one. The first one is 12, after that 25, and third data element will be 37. And where we can insert it, 2 plus 1, that is in position 3. And in this step, rear equals to 3 and front equals to
1.
1. Now the next operation is deletion, that is DQ operation. Delete one element. So which element will be deleted? Suppose insert the parentheses, there is no argument, that means we don't know which item we want to delete. But it's the data structure Q, so obviously the first element will be deleted first. Okay, so we can delete the element from which position? Here front equals to 1, so from this position we can delete the data element. So after deleting 12, now this is our queue with 2 data, 25 and 37, and the position of 25 is 2 or 37 is 3. After deleting one data element from the queue, now the front pointer value will be increased. Okay, so now the first data element of the queue is in position 2, so f equals to 2 and rear equals to 3. Now the next operation is add another data. Okay, so here we can add another data item 42. So the first element is 25, after that 37 and 42. Before inserting the data element, we already increased the value of r by 1. So it's 4, 3, 2. Now rear equals to 4 and front equals to 2. And the next operation is delete one more data element. From where we'll delete it? From the front side, from the front end. So now 25 will be deleted. So after deleting 25, there will be 2 elements, 37 and 42. Now 37 is the first element of the queue and its location is 3. That's why front equals to 3. And the rear element is not changed. Still, the value of r is 4. Now the last operation, that is add one more data. Where we'll add it? In the rear end. So here the value of r will be increased. This is 3, 4 and 5. And already there are 2 elements, 37 and 42. And the last one will be added in position 5. So after that, the value of rear will be changed. Now r equals to 5 and f equals to 3. Here,
Yes, ma'am.
Yes, ma'am.
is that clear? Okay, now the next task is we have to create the algorithm. We have to write the algorithm for NQ operation and DQ operation. In NQ operation, the first thing is we have to check whether the queue is full or not, right? So that can be the first step of algorithm, that is check whether the queue is empty or not. So if empty, If the queue is empty, then print overflow. Otherwise, increase the value of rear by 1. That is, rear equals to rear plus 1. The first step of in queue operation is just check whether the queue is full or not. If it's full, then we can't insert any data element, so it will print the message overflow. Otherwise, we have to increase the value of rear by 1. Then we can add the new data element. If the name of the queue is data, then in that position of rear, suppose rear equals to 4, so at that position we have to insert the new data item. Here data rear equals to item. Suppose here item equals to 55 and the value of rear is, look at this step. In this step, f equals to 3 and r equals to 4. After that, we want to insert another data element. And the size of this queue is 5. That is, max size equals to 5. So at first, we have to check whether the queue is full or not. Is it full?
Yes, ma'am.
How it is full? We are still in this position, in this step. With how many data element? Always the rear pointer will tell us how many data, what is the position of the last data element.
4.
In this position, the rear value is 4. That means we can add one more data element, isn't it?
Yes, ma'am.
In this step, the maximum size of the queue is 5, but rear equals to 4. That means is full is not true. The queue is not full. So after that, we can increase the value of rear by 1. Here, r equals to 4. After increasing it by 1, now this space has created for the new data item. After that, here we can insert the new data item. Data rear equals to item. Data is the name of the queue, so data 5 equals to 55. Clear?
Yes, ma'am.
Is that clear?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. Now what about DQ operation? In DQ operation, we perform at first is empty function. Check whether the queue is empty or not. Suppose now we are going to perform another DQ operation on this queue, where f equals to 3 and r equals to 5. The size of the queue was 5, that means the queue can store 5 data elements, but here f equals to 3, that means 2 data elements have been removed already, isn't it? So now if we perform operation is empty, what will be the result? Is this operation true? Is the output will be true or false?
False.
We'll get to know it from the value of front. Here, front equals to not 0. Front equals to 3, that means still the queue has some elements. So, isn't it? F equals to 3, which means that the queue is not empty. After that, we will access that element. Here, front equals to 3. Now we are going to access the data item. Data front equals to item. We are going to process it. After processing that element here, f equals to 3, after processing the data element from third position, 37 is the data. Now we will delete it. Okay, after deleting that data elements, now we can increase the value of f by 1. The value of f will be increased by 1. So f equals to f plus 1. Then here the new value of f will be 4. So from the value of front and rear, you can say that here front equals to 4 and rear equals to 5. That means the queue still has how many data elements? 2 data elements. One is in 4th position, another is 5th position. isn't it? From the value of rear and front, we'll get to know how many data elements the queue has. Here, f equals to 4, this is the first element of the queue. And r equals to 5, so this is the last element in the queue. So we can find two data elements in two location 4 and 5. So the queue has how many elements? Two elements, 42 and 55. Is it clear?
Yes, ma'am.
Yes, ma'am.
Ma'am,
Okay. Yes.
the relationships between the size and the pointers is not the major thing, right? Like initially it was 5 in size, and lastly we deleted some datas, and finally we got the
No,
4
no,
and
no.
5 pointers.
This is the maximum size of the queue. That is max. The queue can store maximum 5 data elements. That means the queue can have only 1 element, 2 element, 3, 4, or 5 element. But the maximum size is 5. Is that what you wanted to know? Hello?
Yes, ma'am. Hello.
Okay then, so now our next topic will be different types of queue. Okay, that is how many types of queue can use in data structure. Number one, that is, just give me a minute. Hello?
Hello, ma'am.
Hello. Yeah, so we are going
Yes,
to
ma'am.
discuss this topic in our next class. Okay, let me just take the attendance now, and today I'm just ending the class here. Please response one,
Yes, ma'am.
one, two,
Yes, ma'am.
three,
Yes, ma'am.
four, six, eight, nine.
Yes, ma'am.
Nine, seven,
No one is responding. What does that mean? That means you are not actually you're not listening to me, isn't it?
Season 4, ma'am.
Ma'am, 4-5 sound didn't hear we are. That's why.
Yes, ma'am.
The sound is broken.
Sorry.
Couldn't hear you to call 4 and 5.
Okay. Then I'm really sorry. Okay. 7,
Present, ma'am.
8,
Yes, ma'am.
9,
Present, ma'am.
10, 11,
Yes,
12,
madam.
Yes, ma'am.
13,
Yes, ma'am.
14, 15,
Yes, ma'am.
16,
Yes, ma'am.
17,
Yes, ma'am.
18, 19, 20, 21,
Yes, ma'am.
22, 23,
Yes, ma'am.
24, 25, 26,
Yes, ma'am.
27,
Yes, ma'am.
28,
Yes, ma'am.
29,
Yes, ma'am.
30, 31,
Yes, ma'am.
32,
Yes, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Yes, ma'am.
36,
Yes, ma'am.
36, 37,
Yes, ma'am. Yes, ma'am.
38,
Yes, ma'am.
39.
Yes, ma'am.
Okay, so I hope you don't have any confusion in Q or its operation. Do you? Do you have any confusion in these topics?
No, ma'am.
Hello?
No,
Hello.
ma'am.
No. Okay, that's really great. So here only two or three topics are left. That is, we have to discuss the representation. That is how we can represent the Q. Okay, and then the different types of Q. Then we'll discuss about those types. Okay, thank you.
Okay, ma'am.
Thank you, ma'am. Assalamu alaikum.